Hey, can you hear me okay?
Yeah, I can. Can you hear me?
Fantastic. Long time no see. It's been almost, what, 2 hours since our last session?
So long.
It's been a long time. All right, so let's see what we're doing today. We are dealing with which expressions represent the volume of the composite figure, the shaded figure. So um, the basic understanding we want to use here is that we're going to find the total, which would be the prism, and then we're going to subtract the cone volume from that to get whatever is left over. We're doing something similar to this in my calculus class right now. So we have to find the volume of the prism first. What formula do we have at our disposal for that?
Let's see. So we have VC equals 1/3 times pi r squared times h.
So that would be for a cone. So that's gonna be what we use for the cone. But then what about the prism? What about the biggest shape we have on the exterior? The pyramid. Did I say cone? Pyramid. I'm sorry.
Length times width times height divided by 3.
Yep, fantastic. So we have those numbers right before us. So we have a rectangular base with dimensions 7 and 12. We multiply those together, we get 84. And then we're going to multiply by the height. So what would be the height of our rectangular pyramid?
10.
Yep, fantastic. So 84 times 10, we get 840. And then we're going to divide that by 3.
Where are we? Oh, yeah. So that would be 28. 280.
Yes. So that would be the entire thing. And then we want to subtract the volume of the cone that appears inside of our pyramid. So what formula did you have earlier for that? You just said it.
1/3 times 7 times 12 times 10.
So does the 7 apply to both of those shapes, or does the 7 only apply to the pyramid? Because we have a cone and a pyramid. Does the 7 apply to both of them?
Yeah, it does.
Well, take a look. Well, the 7 is only going to apply to this part.
Oh, the pyramid. Oh. So I thought you were referring to the 3.
So the radius of our cone is going to be 3, yes. So then how do we use that information to get the volume of the cone?
We will do 3 squared.
All right.
Times, what's the height? What's the 7? So 3 squared times 7.
And then
will we add or subtract it?
Well, don't forget the pi. We want to make sure we have pi in there too. So then we want to subtract them, because let's take a look at what we're really trying to do here. We have the total, and then imagine you're taking an ice cream scoop and you're scooping this much ice cream out of this container, out of the pyramid container. So when you are scooping ice cream out, are you adding to the container or are you subtracting from the container?
You were subtracting.
Fantastic. So we want to subtract the cone volume from the pyramid volume.
Yeah, so this one. 2.
We should have, yeah, that has pi in it. Cool, just wanted to make sure. Is that all of them, do you think?
But it, the last one as well?
Well, not necessarily, because what we have here is that would be 30 pi. We're only subtracting 30 pi and not 90 pi. So just do a quick check through all of them. Make sure we're not missing any of them that have the same value. Oh, and my internet's not working very well. I just got that ominous message saying my connection is unstable. And in fact, I think I'm going to type this out right now.
Ooh.
Yeah, Yeah, I'm typing this just in case you can't hear me right now.
Yeah, I can hear you.
All right, fantastic. I didn't even need to type that down. Okay. So how do you feel about the choices? All right, fantastic.
Yeah, they're right.
Excellent.
Now we have to start.
Let's see how long it takes to remove all of my drawings from the screen. Oh, that was surprisingly fast.
Oh, it's already gone. Yeah.
All right. An office manager is buying a new AC unit for the company office, represented by the 3D model below. The strength is expressed in BTUs, which are units of measure of how much heat the air conditioner is capable of removing from the air in 1 hour. So an hourly rating of this many BTUs per cubic foot is required. How strong of an air conditioner is needed to properly cool the office? So we're dealing with something in cubic feet. So we have this unit rate, which means that we're going to want to figure out how many cubic feet are in the total. So I like what you're doing there. Marking it up and breaking it up into composite figures is a really great idea. So let's take a look at what kind of figures we have. And then when we have that understanding, we'll understand exactly how to find what we're looking for, find the volume. Oh, are you making those markings, or is the lady doing that?
The lady.
I thought that was you doing that. I was like, okay, you're eager. You're diving right into it, which is awesome. But I didn't realize the lady was trying to cramp our style. So
The lady's thinking. Yep.
She's cramping our style, man.
Unfair.
So I guess, I mean, you can continue watching this if you want, but they're probably going to give us the full answer and then maybe have one for us to work on. So it's up to you what you want to do.
Well, since I can't really get out of this, we'll just have to wait.
Let her have her fun, her moment in the spotlight.
Yeah, she deserves it.
I don't know about that. I'll have to take your word for it. She does look into it, though. I'll give her that. She does look really interested.
Yeah, she's excited to learn.
Oh, yeah. That's really admirable. If you want to know my opinion, I think that's admirable. I think I'll remove my own marks I made on the screen. There we go.
Which marks?
So I already removed them. I just put additional marks on the figure, on that drawing. So do you see what kind of a process she's using here? She broke it up into three different figures, figure 1, figure 2, and figure 3. Just makes it easier to find each individual volume. And then this VFT is going to be the total you get when you add all 3 of those together. So that's what she's doing there. Good job.
How did they get 8?
So the 8 is already there.
Where did they get this?
Where did they get what?
8. This 8 right here.
So the 8 comes from the height.
These 2 8s.
So everything is going to be the same. Everything has the same height. So take a look at figure 3 and then figure 2 and then figure 1. So here, let me use a different color. So I'm going to highlight that in green. So if this green distance right here is 8, that means this is also going to be 8 right here. And this is going to be 8. And this one and this one. So everywhere you see, sorry?
Where did the 8 originate, though?
Oh, the 8 is just given information. So it's not in there. It was already labeled in the drawing. So if you go back to the beginning, you'll see that the 8's already part of the drawing. It's just one of the pieces of given information. Yep. So 8 is just the vertical component of the figure. So everywhere you see a vertical component of height, those are all going to be 8s. So this is the same problem, right? Or is this a slightly different one?
This is
a different one.
the same one.
Cool. Cool, literally. Get it? Because we're talking about AC units.
Oh, cool.
I'm hilarious.
Ha ha ha. You are truly.
I should do stand-up. All right, so we're going to do something similar now. We want to figure out something similar to what the lady did in the last problem. We're dealing with BTU. So we're going to need to find the volume first, it looks like. They ask us for the total volume of the apartment in cubic feet. So let's mark it up in a similar way to the way our friend did that in the last video. So we can start by breaking it up into subcategories. And I have to tilt my head off to the side just to make sure everything lines up correctly. So I broke it up into 3 prisms, it looks like, 3 rectangular prisms. So we're going to call this one A, and then this one is B, and then this one is C. So let's see if we can find volume A, the volume of our very first prism. So I'm going to make another line just to make it clear where the horizontal part ends, just right there, perfect. So for part A, it looks like we're going to multiply 13, which is the height, by 8, which is the length. But then how do we figure out the unknown quantity, which would be this part right here that I'm outlining? How do we figure out the length of that blue part? Do we know that already, or do we have to find it somehow? Do we have to figure it out?
It is 8.
Sorry?
Yeah, it is. Since
Fantastic.
it's 8, since over here the height is there.
Good call. So whenever we're trying to find the volume of a rectangular prism, we just have to do the product. We have to find the product of the 3 dimensions. So this would be 8 times 8 times 13. And if you're anything like me, you're too lazy to do simple maths. So I'm going to just type that in real quick into Google. So 64 times 13 gets us 832. So this isn't the total. This is just going to be the volume for part A. This is going to be 832 cubic feet. Now let's see if you can figure out the same information for part B. We have the 11 given to us, and the 8 is also going to apply. But how do we figure out the measure of the 3rd dimension we need for part B? In other
The 3rd dimension.
In other words, how do we figure out what this part in yellow is going to be? We need that to find the volume for part B.
So over here, we have 5 feet, and over here we have 13 feet. So we'll have to subtract 13 with 5, making it 8 feet in total.
Fantastic. So it looks like we have 8 times 8 times 11. So that would be 64 times 11. And my trusted friend Google tells us that that is 704. So we have 704 cubic feet for our next part. And then see if you can find the volume of our 3rd part as well. Part C.
Where is it? Is it the bottom?
C is going to be this section right here.
So it seems like this side is also 13. So it's going to be 6 times 13 times 8.
Mm-hmm. And we get 624. So see what you get for the total. Now that we found out the volume of each individual part, each of the individual parts, see what you get for the total now.
So I will get 704. $2,160.
Sounds about right. So be right here, yeah. And then the hourly rating of 2.5 BTUs per cubic foot is required. So let's just go see what those options are real quick, and then we'll pick the one that we think is the best fit. So click the list real quick. And then, all right, so it's per cubic feet. what do you want to do now that we know what the rating is for 1 cubic feet? How do we apply that to the total that we just found, the 2,160 cubic feet?
We will have to divide 2.5 by the.
So how do we know
divide
exactly? Sorry to interrupt you, but how do we know exactly if we're trying to divide or if we're trying to multiply? How do we know what the best call is?
Oh, so we're trying to find the hourly rate, and so usually we divide it by 2, don't we? Or
Well, they give us the hourly rate. So this information right here, the 2.5, is the hourly rate. So how do we, this is just for, I think, this is for 1 cubic feet. So it's this many BTUs for 1 cubic feet. How do we take this information and apply it to not just 1 cubic feet, but to this many cubic feet? So this would apply to a very small part of our figure. That would apply to maybe something like this, if we only had just 1 cubic foot instead of all of the remaining space. But the fact is, we're not just dealing with one, we're dealing with the entire thing. So actually what we're going to have to do is we're going to have to multiply that by the total number of cubic feet. So we're going to have to multiply the total by the unit rate, so multiply by 2.5. Because this hourly rating only applies to 1 cubic feet, we're dealing with a problem that has not just 1, but 2,160 cubic feet. So that's actually why we want to multiply, if that makes sense. Stop me if what I'm saying doesn't make any sense. Like, stop me if you have questions about anything at all.
no, I don't.
Sometimes I ramble, and I don't verify that my rambling makes sense. So just let me know if you want me to clarify.
All right.
So Arthur needs an air conditioner that will provide this many BTUs to properly cool his apartment. So we're going to do exactly what we said we would in the previous problem. We're going to take our total, and then we're going to multiply that by 2.5. So see what you get.
$5,400.
Excellent.
Let's say go. All right, next one. Yeah, so this is just a summary.
Mm-hmm. Get to enjoy another video.
Yeah, so great.
Are you having as much fun as I am?
Absolutely. Why wouldn't I?
Glad to hear it. Back in my middle school days, if this were on a projector, I'd probably be the guy doing shadow puppets on the screen right now.
No. Wouldn't the teacher get mad though? Wait, would she even notice? How big would it be? Yeah, how big would the shadow puppet be?
Well, it depends on my distance from the screen. So if I'm pretty far away from the screen, I mean, if I'm close to the projector itself, it would be pretty big. But if I'm farther away from the projector, it'd be kind of small. So it really depends on where I'm sitting in the room. And it depends on the attentiveness of the teacher too, if I get in trouble or not.
Yeah, it depends if she sees you.
Yeah, that's another variable to consider. Depends on if she's one of those teachers who's content to
Yeah.
just sit there and sleep or read or do whatever, or if she actually cares if you're watching the video or not. I've had both. I've had my fair share of both over the years.
Did you ever get caught?
No, I don't think I've actually done it enough times to calculate the risk factor in that. I don't know. I don't know if I didn't get caught or if she just didn't care enough to scold me for it, but success is success all the same. So which right prism would have the same volume of a square prism with a base area of 36 square meters and then a height of 3 meters. So what we can do is we can find the volume of all of these things, the first and then the second and then the third. So we want to find the volume. Sorry, we want to start by finding the area of the base. So the base is going to be this right here. It's going to be this triangle. So let's see if we can find the area of the triangle. And then after we have that, it'll be really easy to find the volume. So we need to, actually it's just going to be 1/2 base times height because they tell us that this is a right angle. It makes things really easy for us. So the base is going to be 3 if we consider the up and down to be the base. And then the height's going to be 6 if we consider the left and right to be the height. So it's going to be 1/2 base times height for the area. 1/2 6 times 3, so that gets us 9. So the area of the triangle is 9. So to get the volume from the area, we just have to take the area and then multiply it by the third dimension, which is 2. So we get a total of 18 cubic, no, sorry, yeah, I was right, 18 cubic meters for this. And then let's see if you can find the volume for the second figure. See if you can find the volume of this rectangular prism.
So multiplying the bases, we would get 18 times 3.
18 times 3 is the same as 9 times 6.
54.
Perfect. And then double 54, what do you get?
54 times 2, that's 108.
Excellent. And then let's do the next one. So we're going to do something similar to what we did in the first one on this page. We have to find the area of the base. And then when we have that, we're just going to multiply that by the 4 because the 4 represents the third dimension in this situation. So they give us the base and the height. So life is good. Base 1/2 base times height. Well, base times height gets us 27. So we're going to do half of 27. So if half of 26 is 13, half of 27 is 13 and a half. 13.5. And then we have to multiply that area by 4. And I'm going to just be lazy. 13.5 times 4 gets me, come on, Google.
54.
Oh, and I guess they actually want us to find this one too. They don't give us the actual volume. They just give us the information to find the volume. So it's a square base. The base area is 36. The height's 3. 36 times 3 is 72. So it doesn't look like any of these have that. So it looks like this would be 72, but then the other ones don't have that same measure. So no, I screwed up. It's not 72. Once again, I failed at simple arithmetic. 36 times 3 is not 72, it's 108. So this right here is 108. So we want to select the middle one then, because it has the same volume.
Yeah, let's go.
Fantastic. All right, so we're going to check all the statements that are true. The composite figure consists of 2 rectangular pyramids. It's kind of trippy if you look at it. I'm not even sure if I can tell what's going on right now. Can you?
Oh, barely.
It's hard to tell where certain shapes start and then where they end. So let me see if I can get a feel for what's going on in this situation. I didn't mean to bring that back. No, I didn't mean to bring back my old drawings back from the dead. Here, I'm just going to clear that. There we go. Have you seen Harry Potter?
I'm pretty sure I saw the first movie, but that's
then the joke I was going to make will make no sense whatsoever. So I'm thinking it's going to be something kind of like this, where we have an elevated prism, and then this other part elevates on a different axis. So they're talking about two rectangular prisms. We know what that looks like. I mean, a rectangular prism, remember, is something kind of like this, and then I'm going to connect the segments like so. So this is what a rectangular prism looks like. So do you think we have two of something kind of like this in the figure? Can you see a situation where we might have two of these in the shape that we're given? Oh, never mind. They say, I can't read either, apparently. They said they're talking about pyramids, not prisms. So a rectangular pyramid would be something like this, where we have a rectangular base, and then all vertices come up and meet at one single plane. Like so. So do you think we have two of these, is I guess what they're really trying to ask us.
Yeah.
Yeah, it looks like it too. I think so too. If we get it wrong, we can just blame it on the quality of their drawing. So it looks like we do want to check the first one. I agree that it does look like we have two of those. So let's go ahead and check that first one.
Let's see. So
go ahead and see if you can check mark that first option. I think that one's true. And then the second one's talking about rectangular prisms. I don't think this one can be broken down into rectangular prisms.
Yeah, I thought so too.
Yeah, it doesn't look like it. So then how do we find the volume of the composite? Oh, I think
we do 1.5.
I might get it a little bit better now. I think it might be like this one, for example, I drew. I think what they did is they may have taken the second one with similar dimensions, like this. I think what they might have done is they might have taken this and kind of just put them together. So they might have just taken this base and then put it like right there laterally so that they're connected. So like I said, their picture is not very good, and that's not just a cop out. It's literally not really good at all. So I kind of feel like that's what they're trying to draw, but it didn't work out that well. Do you feel kind of similar?
Yeah, I think so.
I think that's what's going on. So let's see if we can find the volume. So the volume of this first one, it's going to be one. We have to do 1/3. Hang on, let me look up the formula just to be certain. So we have a base of 1.5. And oh, it's just going to be length times width times height times 3. No, sorry, times 1/3. So we have 9 times 1.5. 1.5 is the same as 3/2, and it just makes algebra work a little bit easier when we have fractions instead of decimals, in my opinion. So this is 45 times 3/2. That would be 45. Nope, that's not right at all. 45 times 3/2. I'm too lazy. And we get 73.5. So yeah, I think that's what it is. Yeah, I think that is correct, if I'm not mistaken. So then the total volume should be what then?
I don't think it'd be any of these.
Let's find out, just to be sure. So I'm going to do 1.5 times 9 times 5, and I get 67.5. So we're going to double that, and yeah, I'm inclined to agree with that. So like I said, their picture's not very good. It's not easy to tell where certain figures start, but based on the information we're given and based on our understanding of the picture, I would say that this is probably what would be closest to our true answer. So let's go ahead and see if they like it. Fingers crossed.
Yep, I clicked on that and it's wrong. I clicked on that and it's wrong.
Sorry.
I clicked on that and it's wrong.
Oh. So, so let's see what I get for the volume. I didn't actually try to find the volume myself yet. So volume is going to be 1/2. No, it's going to be 1/3, and then the product of the 3 dimensions. So it's going to be 1/3 times 9 times 5 times 1.5. And then the 9 is what they both have the 9 in common. They both have the 1.5 in common. But this height right here is 5, so that means the other height should also be 5. So then the total should be 2 times whatever this happens to be, because we have 2 congruent figures, 2 congruent solids. So let's do the math real quick. So 9 times 1/3 is just going to be 3. So that's like saying we have 2 times 3 times 5 times 1.5, not just for one of them, but for the total between both of them. So we're going to do 2 times 3 times 5 times 1.5. And Google is being really slow. Oh, I got 45. I got 45 for the total volume. See if it likes that.
So we did. Yep. Yeah. Oops. So actually, it turns out the first one and the fourth one are the only right ones.
So we
the
did.
Third one's wrong.
Oh, we forgot to uncheck that one. Shoot.
Ooh.
Well, at least we know what we're doing.
Well.
All right. A cone and a triangular pyramid have a height of 9.3 meters. Their cross-sectional areas are equal at every level, parallel to their respective bases. What is the height x of the triangle base of the pyramid? So they have the same height, and the cross-sectional areas are equal. So what I take that to mean is that this circular base is going to have the same area as this triangular base, if I'm not mistaken. I want to look through that one more time and make sure. They have the height of 9.3. Cross-sectional areas are equal at every level, parallel. Okay, yeah. So what that means is that at any level you pick, so for example, we could pick this level right here. The base at this level right here would be the same as the triangular base at the very same level, which would be not that. I'm going to redraw that. So it would be the same area as this would be right here. So if we pick a higher level, we could go all the way up to the top. So this circular area right here would have the same exact area as this triangular part is their point. Pun not intended. So what we want to do is we want to find the height x of the triangular base. So what we have to do is we have to find the volume, we have to find the area of our circular base. We have a diameter of 6, which means radius is going to be 3. So the area of a circle is going to be pi r squared. So it's going to be pi times radius squared. We get 9 pi for that, if I'm doing this right. So then we have the area for the triangular pyramid. That's going to be 1/2. That's going to be 1/2 base times height. We don't know the base. We're going to call that x. We do know the height. The height's 3.3. So 1/2 base times height is 1/2 x times 3.3. And they say it should be congruent to the area of the cone, the base of the cone. So we're going to set that equal to 9 pi and solve for x. So we're just going to divide both sides by 3.3 and then multiply both sides by 2 and see what we get. So x is, hang on just a minute. I don't trust Google when I'm trying to type pi into a calculation. I think I want to use Wolfram Alpha or something else instead. All right. So x is going to be 9 pi divided by 3.3 divided by 1/2. I really hope that I'm doing it right. I get 17.1396, and they want us to round to the nearest tenth. So this is going to mean we just round down to 17.1. So see if they like that.
17.1. Let's see. Yeah, let's go. So, next one.
Oh, they liked it?
Yep.
Fantastic. Which expression represents the volume of the composite figure? So we want to figure out the area of the prism first. We have a prism right here. And then right on top
of the triangular?
Yes, this would be a triangular prism. And then we have a triangular pyramid on top of that. And I don't remember the formula. I'm going to just look that up real quick. Triangular pyramid. So let's see if we can figure out the area of the triangular base first. So we have a base and we have a height. So right here, this is what we're trying to find. We're trying to find this area. It's going to be 1/2 base times height. That's going to be 1/2 2 times 4.4. And that works out really nicely. 1/2 of 2 is just 1, so we get 4.4 for the area. So the area of our base is 4.4. Oh, they don't want us to find the answer. They want us to write the expression. So it's going to be 1/2 here. Let me start over. 1/2 base times height times the length of the figure. So in this case, it would be the base, which would be this expression right here, times 5. 5 would be our third dimension. So actually, we can do the process of elimination on quite a few of these. So we know that this isn't going to match the first one or the second one. And I think we can actually get our answer without doing too much work. I'm really proficient in the art of laziness, as you can see. So see if you can figure out which of these last two it's going to be. See if we have enough.
See.
Well, what makes you think it's going to be this one instead of the last one?
Well, since we're subtracting it, hold on.
Do we want to subtract or do we want to
add? Yeah, we should try to add so we can get the volume of the base.
Yep.
Instead of trying to find the specific.
Mm-hmm.
Yeah. Yeah, nice.
A frustum is formed when the plane that is parallel to a cone's base cuts the upper portion as shown below. What is the volume of the frustum? So can you think of a good strategy that we can use in this situation? I think I can think of one.
We can, what's that?
So I'm thinking what we could do is we could find the total volume. And then once we have the total, we can subtract the top cone to get the volume of the bottom part. So, we have a really handy formula we can use in this situation. It's going to be 1/3 pi r squared times h for the total volume. So let's see if we can figure out our volume first. So we have 1/3 times pi. Our radius we can see is 4. R squared, that's going to be 4 times 4. We get 16. And then the height is going to be not just 6, but the whole thing. So it's going to be 6 plus 3 for the total height. So if we simplify this, we get 48 pi. So 48 pi is going to be our total volume, but now we're not quite finished yet. We have to subtract the volume of only the top part of the cone. So I want to see if you can find the total volume of this part of the cone, and then we'll subtract that from the total. See if you can find this volume right here of only the top.
Volume of the cone, so 1/3 pi times r squared times h. Would the base be 2? Squared? 2 squared?
The radius would be 2, so yeah, we want to do 2 squared.
Ah. So 4 in total.
4 something.
4 pi.
Exactly, 4 pi. So to find, how do we use this information to find the volume of the frustum? Now that we know the total, we know that the entire thing is 48 pi, and we know that only the small part is 4 pi. How do we use that information to find the volume of the frustum part of this?
We subtract it by 48, giving us 44.
44 pi, yep, fantastic. And they already put the pi there for us. So yeah, we're good to go.
Nice.
Fantastic. So A is a right cone, and then B is an oblique cone. So the difference between a right cone and an oblique cone, I can't talk today, I can't say it. So with a right cone, it goes all the way up to the top in a straight line, like an ice cream cone would. But with an oblique cone, it has a bit of a slant to it. So the volumes of the cones are equal when blank. So can you just click that real quick? Let's see what the options are. Oh, okay. So we're comparing A
and B.
So, let's see here.
The volumes of the cone are
You know what, actually,
equal when A equals B.
Yeah, it looks like it to me.
Fine.
And then if A is greater than B, then the cross-sectional area of cone A is blank. So we're comparing the cross-sectional area of cone A and the cross-sectional area of cone B. Can you click that once again? Just see the text that is underneath that. So click, thank you. Cross-sectional area of, can you make the menu go away real quick? Thank you. Cone A is blank, the cross-sectional area of cone B at every parallel to their respective bases. So let's compare that really quick. So if we pick this level, it's going to be the same level over here. So to me, it kind of looks like they're going to be the same. So if A is greater than B, then the cross-sectional area of cone A. So let's illustrate this real quick. Let's illustrate the point they're trying to make here. So we want to keep B the same, but we want to increase A. So it's going to look something kind of like this. My drawing's
so we're expanding the width.
Sorry?
So we're expanding the width.
Exactly. But in technical terms, we're growing the radius. So A is the radius, and then B is the other radius. A is growing, which means that if radius A grows, our cross-sectional area is also going to grow if we keep the same level. So A is growing, B is staying constant, which means that this cross-sectional area is also going to grow, while this cross-sectional area is going to remain constant. So what do you think our answer would be with that information?
Cone A is greater than
Yes.
cross-sectional.
I agree.
Nice.
Toy company
needs
to
package
2-inch radius in sets of 2. They have 2 options, a square prism or a cylinder. It costs the same to produce both packages, so the company wants to reduce the amount of wasted space or space not taken by the balls. Which package should the company choose? So what we want to do is we want to calculate the space not being taken up by the balls. So what we have to do is we have to figure out the volume of just one of the balls. So we need volume of a sphere. I'm going to find the formula for that. Oh, I remember. It's going to be 4/3 pi r cubed. And each of the balls has a radius of 2 inches. So this is going to be 4/3 pi times 2 to the 3rd power. 2 to the 3rd power is just 8. So this is going to be 4/3 pi times 8. This is going to be 32 pi over 3 for the volume of just one ball. But then we're going to double it because every package has 2 of them. So we're going to double that. We get 64 pi over 3 for the total space taken up by the balls. And then we want to figure out the volume of the prism. So that's easy enough. We had 8 times 4 times 4. That would be 128, if I'm not mistaken. It's late. I don't trust myself. I'm gonna just make sure that's correct. 128. So we know that the total prism has a volume of 128. We know that the balls take up a collective volume of 64 pi over 3. So that means the space not occupied by the balls is going to be 168 minus 64 pi over 3. And I guess they want us to use the decimal equivalent of that. We're going to just treat pi as if it were just 3.14. So we're going to do 128 minus 64 times pi over 3. I get 60.979. This is the wasted space if we were to use the rectangular prism as our container.
Where did you get the original 3 from again?
Sorry?
This 3 right here.
Oh.
The 3 that we're using to divide.
Oh, here, I'll just write that again. So that is the volume of a sphere. So a sphere has a volume given by 4/3 pi r cubed. This is just one of those things you remember if you do it for a really long time. This is the volume of a sphere. So the 60.979 is the amount of space not being taken up by the balls if we were to use the rectangular prism. So now we want to do the same thing. We want to find the space that's not being used if we were to pick the cone, sorry, not the cone, the cylinder for the container and not the prism. So let's, how do we find the volume of a cylinder? Do you remember?
Cylinder, well, we will have to, let me see. So the volume will equal base times height, or V equals pi r squared times height.
Mm-hmm. So that gets us 32 pi. And we're using the same balls. They have the same radius. So we want to do 32 pi minus this quantity right here. 32 pi minus 64 pi over 3. (32 pi minus 64 pi over 3). We get about 33.51. That is the space not being taken up by the balls in the container. So it looks like the prism wastes less space. It looks like the prism, sorry, the cylinder is what I meant to say. The cylinder wastes this much space. The prism wastes this much. So which package should the company choose? We want to pick the cylinder so we can eliminate the last two options. But what do you think the answer is going to be? Do you think it's going to be the first one or it's going to be the second one?
I think it's going to be let's see. So, yeah, I think it's going to be the second.
Well, let's figure this out real quick. So I want to take this option right here, the 60.979, and then I'm going to subtract this one. They're talking about comparing the wasted space. So if we do 60 minus 33, we get about 27. So I think it should actually be the first one then. We're finding the difference in space wasted. So it would be about 27 if we do the 60 minus 33.
So the 60 minus 30?
So if we do this quantity right here in blue, and we subtract this quantity here in green, would we get an answer closer to part A or closer to part B? Or I guess,
let's see, so
you think we'd get an answer closer to answer A or
should I round them?
Well, we don't even really need a round. We just need to get something that's kind of close. We just need to approximate it. So if we do the number in the blue box minus the number in the green box, we get something closer to this one or something closer to this one. If we do blue minus green.
We will get something closer to this one.
Yep, nearly identical. All right.
Yay.
All righty. Using volume to determine density. So density is mass over volume. We have a steel hex has two rectangular hexagonal faces and then a hole with a diameter of 0.4 centimeters through the middle. Its mass is 3.03 grams. So they want us to find the volume of the prism. So we have to find the volume. Oh, let's see what the options are real quick. They tell us that the area of the hexagon is 1/2 times the apothem times the perimeter. So let's see if we can find the perimeter real quick of the hexagon. So the hexagon, it's going to be 6 times whatever this value is. It's going to be 6 times 0.6. We get, oh, hang on a second. 6 times 0.6 is 3.6, if I'm not mistaken. Yeah. So the perimeter of our figure is 3.6. So then we have to do 1/2 times the apothem times the perimeter. That's going to be 1/2 apothem, which is 0.5. So 1/2 times another 1/2, which is the same as 0.5, times the perimeter. The perimeter is 3.6. So we have to take this area and then we have to multiply that by the height, which looks like is 0.5.
Could you remind me where you got 3.6?
Oh, so the 3.6 is what we get when we take this 0.6 and then we multiply 0.6 times 6 because we have one right there, the third one is there, and then the fourth one, and then the fifth one, and then the sixth one. So this right here is just the perimeter. So we're going to do 0.5 times A because the 0.5 is going to be the height of our solid. So we have 0.5 times 1/2 times 1/2 times 3.6. And we get 0.45 for the volume. All right, calculate the volume of the cylinder. So this one is going to be easier and a lot more straightforward. So we know that because the diameter of our cylinder is 0.4, that means the radius is going to be 0.2. So the volume of the cylinder, it's going to be pi r squared times height. So we have pi times 0.2 squared times 1/2. And they don't want us to leave it in terms of pi. We're going to have to estimate. I got 0.0628. So we would pick 0.06 in this case then. And then how do we find the volume of the composite figure? So what do they mean by composite in this case?
I believe the composite figure would be the prism.
In this case, it would be
the volume of prism.
The shaded part only. Composite is going to be only the shaded part. So imagine you have the solid hexagonal prism, and then you take a drill, and then you drill. Here, let me get my marker tool real quick. So imagine you drill all the way through it. So if you take a drill and you drill all the way through it and you get rid of this whole area on the inside, the composite figure is going to be everything left over. Everything that's not shaded is going to be composite. Sorry, the opposite. Everything that's shaded is going to be the composite. So we're going to do the hexagonal prism volume minus the cylinder volume. So we need to do 0.5 minus 0.06. So 45 minus 6 is 39. So we get 0.39 if we do the total minus the cylinder volume. 0.39 is the volume of the composite. So that should be our answer for part 3. If we do the prism volume minus the cylinder volume, we get 0.39 cubic centimeters. So that's our answer for part 3, 0.39. And if you have questions, please stop me if you have questions about where I'm getting any numbers from. Just stop me if you want me to clarify anything at all.
No worries.
Cool, 0.39. And then density is going to be mass over volume. This right here is the volume. And then I think they gave us the mass. Yeah, the mass is going to be 3.03. So we're going to do mass divided by volume. We're going to do 3.03 divided by the volume, which we just found out to be 0.39. So I divided them and I got 7.769. So let's see which of those choices are closest to what we have, 7.769. And the units are going to be grams per cubic centimeter for density. So that's our answer for number 4. Let's see which one is closest to what we have. Yeah, lucky number 777.
Nice. We got them all right.
Fantastic. We might have time for one more. And
one more question or one more lesson?
2 minutes left. I don't think that's quite enough time for another lesson.
Yeah. We could work on this 15-minute quiz, but
don't quite have time for that.
Should we end it off right now?
Yeah, probably. Do you want when would be the next time you want to meet up again?
Oh, since tomorrow I'm doing the units exam and cumulative exam, I doubt I can really.
All right. So just text me next time you want to meet up, and then I'll see if my schedule is good. So, I mean, Friday is not really good for me until like 3 in the afternoon. I'm going to be really, really busy from 5 a.m. until around 2:30 in the afternoon on Friday. So keep that in mind.
All right.
All right. Have a fantastic evening, and I'll see you next time.
See you then. Goodbye.